right. If that is all, if there are no more questions, I don't see any questions on Facebook, if I'm correct. No. Thank you very much, Shota. Thank you very much, Imro.
Thank you.
We are going to see each other one more time at 4, which is 4.5 hours from now, with a very brief, short tutorial. Is that right? Is that
Yes.
still on?
I don't know, maybe just one question, maybe it's more to Jan. Is it okay to kind of, because I noticed that there is big break before the tutorial, is it okay to give somehow an instruction what to install so we don't lose time on that, or should I go through installation within the tutorial?
My suggestion is just make the tutorial without that part, or maybe just make it quick, because we only scheduled a half an hour for each tutorial. So maybe people are not going to follow you immediately, but then we are publishing the videos and they can watch it later on. So
okay, so I'm gonna go through it very quickly,
yeah.
and people can then play it with.
Yeah, play it one more time, or even slow down or pause, or so you don't have to wait for people to follow. Yeah, just because half an hour is really a very short time for any tutorial. So
okay, thank you.
Okay, thank you very much, and I think we can just immediately jump to the next presentation given by Jiří Vítek, who is going to talk about his studio at the Faculty of Architecture at the Technical University in Brno, Czech Republic. Are you ready?
Oh, yes.
Oh, you've got a horrible echo there.
So, okay.
Still, you're echoing.
I will suggest I go without camera.
Yeah, this works well.
Yeah, and it will work.
I think now, because I need to go to my other computer, you are probably not able to share your screen. So maybe just give a brief introduction without sharing the screen, and very quickly I will allow you to share the screen. Just so. Cool.
Okay.
It's your time,
guys. I'm very happy that we can present in this wonderful meetings our work. So basically, I was whole studies wondering what architecture is, what is boundaries, how we can push the boundaries of architecture, and how we can understand kind of ontology of architecture and develop more and further and better understand how we can participate in this amazing journey of architecture. And luckily, I set up the studio in Brno, in Czech Republic, after my studies in Vienna at the Angewandte in Zahadi studio. And I will go through a couple of projects, and we have like first year students, which are in kind of module, which is called kind of basic architecture designing. And in this topic, we are trying to show the students how can they understand how to develop the ideas, what others dealing, how they are dealing with the architecture. So basically we started with a couple of examples and exercise. Not mostly we are starting with buildings. We often start also with paintings and sculptures. And the like last 2 years, the paradigm was about how to understand the connection between architecture, arts, social, politics, and these kind of things. And we are really focusing also on theory part. So students are kind of pushing to read, to really understand the discourse and agenda. And then we are leading them to really base kind of their own project, their own understanding, and then they are able to build their own project, which is crucial. And from the first year, then we have kind of Also in the university, there's kind of standard setup that you starting from the small scale, then you go to the housing, then you go to the urban project, then you can go for your diploma, and then it's you should build your own project. But we are kind of free to set our own teams and domains, let's say. So sometimes we are focusing on urban, then last year we were focusing on the music and architecture, also the anatomy of human and connection to the architecture. And so now I am able to share.
Yes, yes, you are.
And so I will show the projects from the beginning, from the first year students to the end, to the diplomas. So firstly, you see, all of you see the screen? It's fine?
Yes, it works for me. Yeah.
Cool. So basically, the first task is to build a bridge or tower from the small parts, and there's no other kind of troubles what you should solve. So this task is only for 1 day, and it's bringing very interesting ideas. And then we move to the arts and translating to the kind of 2D representation into the 3D. And this year we were interesting how to change the typology thinking to the topology thinking. And this is typological model of Malevich. So they built kind of primitives and then hang these primitives into the 3D frame. And then they were pushed, build this idea in the topological thinking. And this was the model, because in the first year, we are not starting with the digital tools, we are starting with the 3D models that you are able to easily translate the ideas into the architecture prototypes. And then based on this experience, you are able to see, okay, I'm interested in this, and then I am able to build my digital model. This year, the first year students analyzed the church in Czech Republic by Santini. It's kind of very interesting Baroque architecture. And what was very interesting in Santini, he actually built his own architecture language. He's connected Gothic language with the Baroque one, and he is almost the first one who used diagram to kind of generate the architecture. And we start to analyze the building as in terms of structure and language and, let's say, program. And there are so many analyses of Santini, but we're trying to find really kind of new way of understand this amazing architecture. And the students really did great work. They start find kind of basic curves which generate the, let's say, plan. But then we went further to see, okay, if Santini was kind of in 17th century, what was the kind of knowledge of the world? And we find that he was really interested in Cosmographicum, which was written by Kepler. And then we applied this model to the church plan, and it was actually fitting into this plan. So then we think about how we can, if you will be in this position today, what you should kind of visualize or build in this idea. So if Santini built kind of universal representation into the architecture, what kind of representation it should be today. And students find very interesting idea by Wolfram about how the particles can emerge, and they found the rules and then build kind of code from this, and they started to play with the form, and even they were not very happy when it was very kind of organized and so similar to Santini. So they push forward the geometry to find kind of new representation of this, and they build kind of different iteration, which is also based on the kind of math diagrammatic thinking in Santini. And upon this, they start the new language and new organization. And what is fascinating, that this is kind of first year students, so it's not kind of that you should study for 5 years to go for this kind of advanced projects. You can start immediately if you have kind of this option, you know. So, and basically they end up with this kind of 3D form, which represent the understanding of also the Baroque architecture, but also the current state of architecture, which is very interesting. So basically also because this coronavirus issue, we were mostly digital. So instead of physical model, we end up with this digital, but mostly in the first year, you end up with the big physical model. So this will be printed afterwards. Then if you are second year students, you should go for those buildings. Like mostly they go for family house. And we did like, let's say 9 of very interesting canonical buildings from Mies van der Rohe, Eisenman, Remkoolhaas. And in this case, we studied Adolf Loos. Maybe you know about this guy. And actually he was born in Brno and he was set up in Vienna, and he was inventor of Rauplan. Before this, we did a small, like 1 or maximum 2 weeks exercise about Palladio, but the Palladio is quite very interesting, very deep guy, and we given not so much to go for whole semester into this, so it was just the first kind of exercise to get the right speed in the students. So all the teams did the short analysis of Palladio, and then they moved to the Villa Miller, which was very interesting how the students keep the model of thinking from one building to the another, but it was successful. So they started to analyze the person, the architect, who was this guy, what was his experience, why he did this. And it's not just kind of, you know, thinking about, okay, he did just building, but what was the message of his working. And then you can find so many paradoxes because the Loos is mostly known according his writings, that he wrote a essay that the ornament is crime, but this understanding is quite funny in Czech Republic because now everyone is thinking that form is bad, but it's according to like teaching method and understanding of architecture is. And we, with this exercise, we analyzed that it was not true, that he was very much interested in the form, and he developed the idea about the thinking as a building, not as a plan, but as a volume. And this was the proto architecture model, where the most interesting is kind of spacing and kind of ordering the space into the deep vistas, deep connections, and also a very interesting idea about the Nietzsche, which is kind of orienting the person into the, let's say, space. So So there was also analysis of program and analysis of structure. In this analysis, we actually found the very interesting connection with the Palladio, because the laws also using the same organization principle as the Palladio in the 9 square, but he is also like a little bit moving those columns outside of the grid according to program. So it means you can also use kind of the diagram, but it's not necessary to be so strict. You can a little bit play with this, but you should be aware of this. And this is about the addition and division of the volume. So it was very formal, even if it's not so known about this. And this proportion game, you can also find this kind of analysis in Corbu and Palladio and others, and even Remkolhaus, which was also surprising. And in terms of symmetry, laws using very interesting game that it seems to be symmetrical, but it's not really. So even if there is a missing some kind of window or parts, it's appearing in somewhere else, like you see in these diagrams. And they actually analyze the proportion methods and make kind of formula, and also the idea about how you move through the building and what you can see. And for this, we starting to use digital tools. And so basically they build a digital model based on volume, kind of proportion, vista, visualization, and scale, and build these proto architecture models. So basically she start to build diagrams. From diagrams we go to the proto architecture, and from proto architecture go to the final building or final project. And which is very interesting if you also follow the structure, how the students thinking, and you can see the kind of stream of developing the project, and then you are able in this process see where it's kind of missing the step or if it's really flowing nicely. And this is the final project. Then if you are in the third year, we are really interested in urban design. And I don't know how it's in Bratislava or in Turkey, or we struggle a little bit with urban thinking, because the, let's say, the approach of urban design and how it's teach, it's kind of very modernistic and it's not critical. And we see that the city is now in a very critical position, and we should really think about it differently, because mostly it was based on, let's say, top-down thinking, and it's not relevant anymore. And also, if you are in this typological thinking, it's very difficult to change the paradigm. So we tried to change the model of thinking. So we went to the topological thinking. And if I just briefly show you what we did. So basically we started to analyze the street structure in terms of connection, in terms of public, semi-public and private spaces, build the diagrams and build a, let's say, algorithm which are able to analyze the connections and say, okay, this connection is more efficient than this. And we tested in a couple of examples, like in Hradec Králové, in Brno, in Školber Park, and then the students build up their own algorithm which were able to generate the new connection points. And with this kind of deep mathematical understanding, we were able to generate the new connections, a new, let's say, network. And this helps us to change really kind of model of architecture. Based on these topological studies, we are able to translate the model into the fabric, and then according to the forces inside the city, we are able also to analyze, but also to generate a new situation, which can lead us to the new, let's say, typological understanding of the things. So basically you start from analysis of the typological thing, translate it into the digital topological model, and then you can translate it into the, again, new typology of the city. And this is the behavior of the fabric, and they have this kind of approach to build a new spa in village, and this is the final result. And then I would say that we a little bit struggle, but because yeah, we have form, but then we should go further according to validation of projects. So then it should be really, because I'm not very happy with this glassing patterns and translation in, you know, just the simple mesh shape into the structure, because you need more understanding what structure is and what kind of space it is, and it's the next step. We will go further, and it's also that during the, let's say, project, sometimes we see, okay, it's going this, then we can change a little bit the kind of direction of the project, and then we see, okay, we should continue, for example, next term with this and go deeper, because it's not only about the idea, it's also about to really make it proof this design. You know, for example, if you are happy with this, then if you go to process that you really want to build this, then it's a lot of work what you should do. And another idea was the anti-pandemic city, because the old city, it was very interesting. When the lockdown was in the city, the streets were really empty, and then the city disappeared somehow. And what was working was internet and all the another networks. And we think with students, okay, what should be kind of reaction on this? And they bring this idea about the layering, or build a level above the city and make kind of parks, because all in Brno only parks were work and there were so many people. So what if the park will be part of the city, kind of in layering? And yeah, this was the result. And the issue was how to integrate different programs, because it's not just to build kind of, let's say, bridges or landscape issue. It's also about how you can build program into it, and then it's going to kind of different thinking about the thing. Yeah. So then it was a very interesting project about the music and architecture. Maybe all of you know about Xenakis pavilion for Philips in 58. And yeah, this is the model. So the students start with the physical model of the Philips pavilion. And there's so much about architecture and music. And it's very difficult to say, okay, I will go in this or that. So it's we consider that it's much better to build our own understanding or our own approach on this. And we said, okay, if we really want to understand the problem of the composition of music and architecture, we should start from notation. Because if you go for sound or kind of spectacular algorithmic music, there are so many options. So we were really strict in this, and it brings us so very interesting results. So they really start from really basics, how the homophonic and monophonic music, polyphonic works, how the beat works, what is the notation, what is the rhythm, how you can work with rhythm, and they build the first model of the rhythm that you are able to play with this. It's also interesting that now we are going to build this kind of really musical instrument based on this research, that these kind of columns represent the beat and, let's say, tone, and according to placing in different positions, it will play a music. And then they analyze the air from Bach into this diagram. So they built also, this is a physical representation of this music. And it's also very interesting thing that if you have music, it's kind of linear. There is also a connection with the time, and you are not able to see the whole kind of part of music in the one whole. So it's only, you see only parts. But when you translate it into the architecture model, it's, you are able to see the whole thing. But then if you go to the spaces, you are also able to see the parts and also patterns. Because what in music, it's very interesting that you are able to see the patterns. There is a repetition, there is a transformation, as well as in architecture. So they translated these patterns into this, let's say, 3D diagrams. And it was still part of research, which lead us to, yeah, maybe I will finish this and then we can answer the question of this project, and I have two more. So then we were thinking about a chord from the basic one to the more complex, and in the same, let's say, algorithm, we build the sequences of the chords, and then it leads you to kind of repertoire which you can use as an architect. And yeah, we were happy with this result. Also, the digital model was translated into the physical one, like you see here. And with this, we can, we are going to build an instrument. So let's see. This is still about the chords. And then we were searching and understand, we tried to understand the scales. And even if you see the slight differences, there are some. And then we finished with kind of music pavilion for the jazz festival in Brno, which is a really famous festival. So they built kind of repertoire based on Leoš Janáček, Eliška Bystrouška operas, and yeah, this was the final model. Maybe I am able to answer the question if there are some.
Well, I would like to ask, how was the what is the tools you analyze in music and translate to the architecture space or pavilion? Like what kind of tools you used?
Basically, we use Grasshopper for everything.
Only Grasshopper?
Only Grasshopper in this case. There are so many, like you can play with Design Touch or Touch Designer or others, but there was struggle with translation, this kind of representation of data into the 3D. And because it's really about how you understand the model and how you articulate the model, so the Grasshopper are able to
lebo to je to inde, ako je ten Facebook.
everything.
Vypni ten Facebook, prosím.
Yeah? Do you hear me?
Yes, we can, I guess, but the Facebook voice was coming. So now it's okay.
Yeah. Okay. So even in Grasshopper, there are kind of add-ons like Firefly that you are able to capture sound and translate the sound into the geometry. So you can use this, or you can use coding like processing or whatever. And yeah, there are so many. Even if you go to the understanding of music and architecture, you have really so many options how to work with this. And yeah, we use, because also if you go this, you translate the notation into the diagram. So basically on the x-axis, you have the rhythm, in the y you have notes, and then you build this kind of representation. Yeah, okay. And still we have a couple of minutes, so I can show you our diploma projects. One, it's based on architecture anatomy. Okay, and this guy actually studied the.
It seems like there is a question or request to
Okay.
show the analyzing part again. Was that what you were doing recently, or because it's a very fresh one? Probably.
With the music.
Yeah, I probably did, right?
No, it's last semester.
No, but there was a. Okay, never mind. Continue. It was redundant what I said.
Okay. So this guy actually studied the body and organs and how they are operate during, and ambition was translate this organization and functionality, let's say, into the architecture objects. And actually he built kind of machine which work with waste in the city. So you bring all the waste in this tower, and the tower will clean, you know, the bio waste, also water, also air, in such a very interesting way. So there's in architecture, there's a kind of differentiation between what is machine, what is skin, what is structure. And all these things were built in Blender. It's mostly like hand modeling, and it's quite interesting shape. So it's open, like it's your decision. If you go to the coding and, you know, like artificial intelligence, or if you go to hand modeling, it's up to you. And it could be also very powerful. Then, okay, then we get this guy who were actually thinking about the architecture. It was big struggle about what architecture is, what is the role of architecture in the society, what is the ontology of architecture, if we are free or architecture around us kind of frame us. And he was interested in game of life and how this particular approach can be translated into the architecture. And he think about, okay, if there's a kind of like home or cell for living, there is potential to build a kind of commune, kind of public spaces. And if there is a commune, there is potential to build a garden. And in these three different sets, they run the algorithmic process and build, let's say, kind of organization of this. And then you also have to make a decision, because in this kind of generative algorithmic approach, the time is crucial. So you can say, okay, I am making this analysis and I will stop somewhere, and then this is the final state. But in the reality, it's not like this. It's changing. Everything is changing. Even if you look at the city, so it's still in kind of process. Something is, destroyed. Something is built up. So he developed the idea that the building is still changing itself. So, but if you have this analysis, you can predict what the change will be. So, for example, if you, and then you see this iteration thing. So even if there is like 200 cells for living, there should be like 50 cells for garden or so on. And it's changing during the time. So there is a kind of public space cell, garden cell, and living cell. Then you can aggregate them and kind of make a new typological scheme, new kind of experience. And then he showed the iteration number 115. Why this one? I don't really know, but this was the change. And yeah, it's very interesting if you would like to really validate and show or draw the planes of this process, because it's kind of endless changing machine. And so, but you should show it, even because this is diploma, so it's not allowed to have a diploma only like a geology, like algorithm. You should show the plans. It's kind of obligatory. And the building operates that on the top, and in the middle there are robots that they operate with the cells and changing the cells. And also the idea that it's not just one closed system, it's kind of very open system where you have factory which build these cells and moving the cells into the certain buildings. And this is the mechanism of the robot and cells, how they pick the cell, how they move the cell. And this is the structure of the cell. And this is the manifesto, which is also very interesting, that it's not always that you show like the previous one. Okay, this is about the beauty of the structure and machines. And this is more kind of philosophical thinking. Okay, what is architecture? If we are in this kind of prison-like building, what should be advised, or how you will live in this kind of situation? And it's very connected to the super studio and this kind of manifestation, also the Peter Cook projects like this. So I have one more, or we can have short questions if there are some. Jan?
Yes, I'm here. I'm here. You still have like 20 minutes if you want to show something more.
Yeah. So I'm going to show you the last project, and then let's say we can have questions. Is it okay? So this project is about the farming. The idea was about, if the city is growing, then we lose kind of the gardens and the ground for making the food. So what should be next step? How we can deal with this, and how there is also already there are kind of farms and robotic farms which planted the food for us, but it's located outside the city, and then you have trouble with distribution and traffic, and how we can change this. So he studied kind of way how to plant flowers and fruits, and what is important is light. So according to different kind of light condition, it's also according how the plant is in the process. So at the beginning they need the different spectra than in the final state, and if you control this, you are much more efficient, let's say. And they studied what kind of food we need, what kind of calories you can get from this, and there was also inspiration how you can get water for this. And this is very funny diagram that if you have just the field with the plant and the sun is going, right? So then you can place the plants into the kind of vertical aggregation, but still you don't deal with the light. So, and it's not so efficient. So if you would like to be efficient, you should increase the surface area. So he started with kind of very growing patterns to get as much volume as possible. And this is kind of artificial light placed inside a cell. And yeah, so he started with this when he built kind of algorithm to grow the cells as I mentioned before, but there was the trouble with the robots because we have such an interesting shape, but it was not so efficient for robots. Maybe, and yeah, he also kind of worked with this kind of parameters which are very needed. So for different plants, you need different kind of volumes of the cell, but you should be careful that the cell will not cut each other. So he controlled this growing pattern, but even if it was very nice, then if we placed the robot inside, because the idea was really use kind of this arm robotic KUKA machine, so that it was not so efficient. For example, these parts were not really in right distance, and because the final thesis should be also kind of valuable for the whole university, so we were a little bit more kind of realistic to change the model into the kind of robotic vision. So we translate the operation space of the robots into the system. And then he studied the city, what kind of, how many people you have, what is needs, how many calories you need, how many different plants you need, and all these measures leads to the different kind of cells. And so he defined kind of 9 different size of the cells, from small plants to kind of bigger and the trees, and build this kind of organization of the tubes. And even if it's kind of realistic, because it's not so geometrical interesting like the pre-thesis, but it's, you are still able to kind of insert the beauty of organization. And also it's very interesting, and particularly I would say in our studio, that how you implement the context into the digital model, because in this case the context was translated into the kind of this free orientation of the grid, and in this grid the tubes are growing in the one time, so you are able to control the growing system. And then this is catalog of the different tubes. Then of course you need kind of structure water, infrastructure, electricity, all the stuff. So this is the basement when there is a kind of import and export of the necessary needs. Then you have plan of the different tubes and the structure. In this case, the structure is not so optimized. That could be also more kind of differentiation between the structure and where the force flow is going. That should be maybe a little bit lighter and then stronger part, which can bring kind of new layer into the project. But it's still quite nice and complex. And this is the section. Yeah, and then it's kind of machine vision of the architecture, but it has still kind of really beauty inside. And this is the site. Yeah, and kind of diagram. So in thesis, you should really show and validate the project that is understandable for all. Also, we should make a details. Yeah, and there is how it looks like. Inside, yes. And yeah, this is the particular situation in the Brno. So we have one tower, and then this area, it's really kind of abandoned now, but we can imagine that this is the kind of new, really interesting part of new city. And that's also kind of academic part that you should not just to make, okay, this is needed, but you should predict the future. You should say, okay, this is the option, this is the future, this could be possible to go in this direction. Like last year we did kind of hyperloop station in Brno, and yeah. So is there any question now?
Yeah, if you look into the Zoom chat, there is a question for you about the body organs project. The mechanism of the ventilation and the airflow is similar to our respiratory system and our lung. That's the question.
Yeah. So yeah, where's the chat now? So yeah, basically, it's very based on understanding of our respiratory system and how it works. So there is a, not in these images, but there was the analysis how the respiratory system it's evolved during the different organism and how the complexity is increasing and how this complexity is really possible to translate into the architecture model. And all this stuff, all this kind of analogy thinking is really based on how we operate, how our organs are operate. And it's also very interesting, this idea that you bring yourself into such a machine that if you go through these processes, you can start understand how your body actually operates. And maybe later, because this thesis is really now defended, so later on we can show the video of how this building operates, which is not unfortunately here, but then you see all this machine, how they actually works. It's a little bit visible in here. So basically you have respiratory system, then you have kind of stomach, then you have livers, and all these organs translated as a mechanism into the architecture. Yeah. Is it okay like this? Unfortunately, I
Yeah.
don't see the chat. Yeah?
Yeah, I think yeah. It seems that it is. I'm also checking Facebook. It seems like there are no questions on Facebook. Let me double check. But it seems like so far so good. No, I don't see any comments on.
May I speak?
Oh
Yeah,
yeah,
sure.
sure. Go ahead.
Yeah. Firstly, thank you for showing all the works, which was like stunning, and it was so good to see all of them. But the thing which I want to talk now, recently I had the opportunity to see one article about craftsmanship in a way in computational design. So the project which I want to talk now is about the church project which you have done. And in that, you were saying the students were not really happy about the results. So what was the thing? What was their aim to reach? Why they thought this the last result was not satisfied?
No. Actually, yeah, they were not happy in this stage when you see this, where
Yeah.
the organization was still based on the Santini diagram, and it was very much similar to the Santini. So it was kind of, you develop your own kind of understanding of architecture element, what architecture is, what architecture represents, but then you actually still using the organization principle from the Baroque. And this is this spiral thinking. And then that was also a very interesting discussion with the students, that I asked them, okay, if you are not happy, if you don't like this, why? You should articulate why you don't like this. And they say, okay, no, it's so symmetrical, it's so obvious. So we discussed this, and the result was, okay, don't do what you don't like, change your thinking, change your paradigm. It's not necessary to be so literal or so stick on the organization of the Santini. You can change it. So go forward. And they start to
While
thinking
they are
differently.
interpreting, are they only use like the geometry, or is there any different aspects they care about, like sounds or like the international, like the relation between the environment and the context, or like what was the parameters they took from the church itself?
Yeah. So actually in the analysis, they study also sound, and in Santini, it's the most important thing is light, because he built the the spaces as there is no shadows. There should be always light. And he was, in this case, very different architect, because he was not so interested in plan. He was interested in the sculpture. So instead of plan, he built a model. And the students actually built this kind of approach based on light conditions. But if as an architect you can spend so much time on integrate all this aspect into the one thing. And in this first year exercise, we kind of challenge the students, take one thing and make it really real. So it's not kind of final super efficient building. It's about testing and exercise possibility of architecture. So for example, the final model, it's not based on light or condition of site or kind of context. It's based on this physical understanding is Wolfram theory, and kind of apply this theory into the diagram of Santini and more play with the form and its meanings actually. So
Could you tell about more Wolfram aspects, like what was it?
Yeah, it's a difficult one.
Okay.
You can really check this. It's very, very fascinating. And it's also fascinating that students actually were not able to do that alone. So they ask one of their friend to help them with the code. And actually, you see the rule in the left, like here. So if they are like 3 particles, they're trying to find 2 vectors, which go from AB to BA. And in this position, there is a possibility to generate a new particle. And in these rules, you are generating more and more particles. And the position, it's not relevant. It's not necessary to know where the particle will be, but it's very crucial that there will be this connection of the vectors. So it's more kind of topological thinking and model. And it also works with very crucial thing like the randomness. So according to this tendency that you know if there is a disposition of the particles or existence of the vectors, there will be a new one, and it's not necessary to know where it will be. So randomly you generate the new particle and then analyze the vectors, and in these vectors you generate another step, like this diagram shows. And from this, actually the whole thing is generated. But this diagram is based by Wolfram code. And we were not able to get code from him, so we tried to make own, which is actually here.
Thank you so much.
And if I just add, these are numbers of iterations. So in this 12, you have 12 points in this increasing the complexity, and you are not like, you don't know what the final form will be, but you know what the topological kind of connection will be. And this is the another kind of step of articulation and, let's say, architecture representation, which could be discussed also. It's not necessary to wrap all the lines. You can develop your own approaches for this.
Okay, I think, thank you, Jiří. If there are no other questions, I was actually wondering if you are going to have a presentation for the entire hour, but it seems like you are very precise, so yes, you do.
Yeah, I have more projects, but
you do?
Not necessary.
do you want to show them?
Not necessary. Actually, we have this final stuff, so I would like to go upstairs to see if the people defend. Well,
all right. No,
okay.
also your slot is already over, and we should move on to the Studio Data Lab at the Technical University in Bratislava. But thank you very much. It was very informative.
Thank you.
I always when I look at the projects from your studio, they look like they look very contemporary. For me, they also look very connected to what is happening in Brno, which is something that I was that we were also discussing in the first session. And also, you always bring something that is from an outside discourse in a way. So also you have this Wolfram's physics project. I think I mentioned it during the midterms, right? That this exists, and for me, it's always very fascinating to see how can you actually incorporate various things into a contemporary digital project. That's impressive.
Thank you so much.
I mean, also congratulations to your students, because yeah, it's
definitely
obvious.
About them.
Yeah,
it's about them.
It's obvious that it's about both of you, because they need to get inspired, and also they need some guidance, but at the same time the passion needs to come from their side, and it's obvious that both of these things are happening over there. All right.
Thank you so much, and good luck.
And good luck to the students for the finals.